Okay, great. So I suppose we can start working and making another step in C++, finding out some new things, new opportunities you can use. All right, so the recording is activated, so things are fine, and I will share my screen so we could be working as all the time we do that. Okay, so looks like you can see my screen at this moment. Okay, and let's take a look on our materials which we have so far. So what do we have for now? So we have this for loop, both examples and tasks, as a regular we have, and materials for the while has been uploaded as well. Let's see, maybe we'll overlook them both. Who knows? Okay, so let's start with the for loop. Okay, so oh, how the for loop is being formed and what is it? Um, in C++, as in whatever other programming languages, there are such things as texts. And literally, if we would try to, for example, analyze text, and we would be trying to maybe analyze each symbol of the text for some purpose. Right now, it doesn't really matter why we would do that. The main is that there is such possibility. And we can literally name each of those symbols in a text by, well, in whatever manner actually. We can give we can give an indexation to them. We can give let's say names of those letters in the text, or actually there could be whatever way to do that. But what is interesting, if we are capable to, let's suppose, give an indexation to characters in the text. Well, for example, if we have, let's say, text, the text has characters, right? And we can say, okay, the first is T, the second is H, the third is I, the fourth is S, and so on and so on. That's the idea. So if it's possible on the logical level, well, because we can talk about that, we can imagine this. So in the similar manner with the similar possibility, it's possible even in technical implementation. And what is interesting, we can literally go through the whole text, for example. In a similar manner as the cursor when it goes through the text. So in a similar manner, it's possible to go through whatever structure, which elements can be let's say pulled in a row. So that's the main narrative of the for loop. So literally, for loop allows us to change the value starting from a specific value, ending with another specific value. That could be probably the most simplified description of what happens within the for loop. So the for loop contains of several parts. So initialization part, as we call that. So literally, it's the part which will be executed only once before the for loop construction. Then we have a condition. Afterwards, I will describe what is specific about this condition. So the condition is being specified in a similar manner as in if statement. So we write some equation, or we make some comparison, or we use some comparison operator that gives us in the true or false value. Actually, like in if statement, everything which is written in a so-called end condition, but I call it mostly as a condition of continuous execution, will be converted to true or false values. So it should be noted. And the third part of the for structure configuration is a code which will be executed each time you finalize iteration. It should be noted. And this time we need to talk about, well, what's iteration exactly and how we can use that. So after such construction, you have to define an entity which will be executed, which will be run each time the condition gives you value of true. And this entity, as for the if statement, can be defined by one operator or by a set of them. And as you know, the set of operators is being structured as the kind of block of operators between curly brackets. So idea here is the same. So a description about this for loop, as I said previously, is pretty simplified. And afterwards, you will get how it really works in an advanced way. So let's suppose we have the code. Let's say the testing code. So what do we have here? So we have variable I, which value will become 1 before iterations, before any amount of times these executable operators will be run. So the first part, this one, will be run only once. Then before execution of each next iteration, literally this code. This code which we wrote in a second section will be run. And when it gives you true, value equal to true, then another iteration will be run. If it gives you false, then the for construction breaks. Well, in a similar manner as switch construction breaks, which we overlooked previously. And the third block of the codes will be run each time you finalize an iteration. That's the idea. Sometimes people call this a variable which they set up here as iterational variable, which is correctly only in the case when this variable is involved into some executable operators, like in this part. But most likely just some sort of calculations of how many times we have to run iterational code. That's it. Well, mostly that's the idea. So maybe let's take a look on one of examples. And here we'll have the app that calculates summation of the first 10 natural numbers. Well, let's call them maybe integer numbers. What could be that example? So we have a variable of summated values. So, and initially its value is 0. We have some variable which will be involved within for loop for understanding how many times we are running iterational code. So where iterational code exactly is. So here we have set of instructions, and this is exactly the iterational code. And let's take a look how many times it will be run. So we have the code which will be executed before the first iteration. We have the condition which will be run before each iteration. And we have the code which will be run after each iteration. So first value of I will be, of variable I will be 1. And iteration will be continued with this condition. So while I is less or equal to 10, then iteration will be continuously executed. So which means that the last value will be printed out by this cout will be a value of 10. Yeah, and afterwards there will be a printout saying um, the first 10 integers summational value. And surely in the end we have system pause, which literally waits until we will press whatever key on the keyboard. Okay, so literally the printout of this application will be so we have a printout from 1 till 10, and their values are being summated, and the result is being printed out in the end of the following text. So first 10 natural numbers, summation is, and then 55. That's the idea. Okay, so here we have a small text about those curly brackets, but about the curly brackets we already had a talk about. So the curly brackets idea is same for every component and every construction of a C language. And here we have a small description of how this application is being run. What happens within this application? Okay, so firstly, sum is equal to a 0. What will happen when variable I becomes 1? Well, this will be the summation. So previous value plus a new one. When it's 2, so it will be the previous value, which is 1 plus 2. When I becomes 3, then it will be previous value again plus 3, so on and so on. And that's the ways you can see step by step the value, the summational value will become 55. So literally that's the way how it happens. Are we good so far? Maybe we have some questions at this point. Okay, and I see we have a new student here. Okay, yeah. Well, I got the message about you. Yes. Okay. So, yeah. So, hello, Anana. If there will be any problems in asking something maybe in English, because who knows the level and so on, you can always ask in Russian if you like. Ну, как-то так. В общем, не переживайте, если что, спрашивайте. Можете по-русски. Okay, so let's continue the content. So if we are good so far, then it's great. So let's take a look on some other examples. Well, let's move forward. And what is interesting? So here we have another case. So some people tend to say, and by the way, you will find out on the internet that literally for loops being executed like from starting from the lower iterational value till the biggest one, and a lot of people follow that idea, but it's not really correct, because by the fact you can write whatever codes in these three components, which sets up the for constructor. So, for example, here we could make things a bit differently. Let's say again we have 10 first integer numbers, but how the computation happens? In this case, as you can see, we start computations from a value 10 till the value 1. Actually, here we have kind of going from biggest value till the smallest value. And here again, we have such constructions as I minus minus, which actually is I is equal to I minus 1. This is the very, very famous construction, same as I plus plus, which may be no, it was not included in the previous example, but anyways. So So anyways, this construction like I minus minus reduces a value I by 1. Literally, it means I is equal to I minus 1. And things related to iterational part of this code is the same. So we're just summating values. And that's it. That's the whole logic about this. So as you can see, you can pretty flexible create this for constructions. And by the way, things which we overlooked are not limits of for constructor. So there are much more interesting stuff related to this. Okay, let's take a look further. Okay, well here we have a comparison of executions of both codes. So you don't have to be surprised because you can always create such tables of changed values. Well, from my experience, when I was studying on bachelor's, we pretty frequently created such tables just to make sure our computations predicted correctly. So maybe you can try doing the same. Okay, so let's take a look on the next case. So let's suppose we will have the following things. So we'll be printing all even numbers in the interval between 1 and 20, and we will be decreasing value. So let's take a look how it's possible to be done. So decreasing, so it means you'll be working with from biggest value till smallest value. So we'll take a value of 20. So even values, right? So values which are divisible by 2 without remainder. So what is the settings of a for loop? So we have I equal to 20. Okay, the biggest even number we are working on. And here we have a condition of iteration execution. As you can see from this case, from this example, it's not really necessary just to have one operator. You can have maybe a few comparison operators. You can have a combinational operator, which you already know, like it means the logical AND. So the question for you guys, are we good with logical operators like logical AND, logical OR, logical NOT? Are we good with that? Or we need a kind of reminder about how they work? Yes, okay, so let's remind how they work. I will be using the following ideas. So I have the logical operator, and I have its kind of value on the left and value on the right, and I will make an assumption that the results of these operators will be true and false. That will be necessary for a simplified description about what is logical AND, which is written in such a what is logical OR and what is logical NOT. So I will need an Excel, so I will be opening my Windows system, and I will go for an Excel. Okay, that's great. And I will be doing the following. So I will say, okay, I have A, I have B, and I have equation A and B. Okay, so we'll be overlooking things in a such way. So the possible values here could be true and false for both of A and B. Since we have two variables, so we have potentially four cases. Now let's take a look on them. Okay, so we have four cases. Okay, and we can make a computation of logical AND for all of those four cases. So how a logical AND works? So it gives you true only and only when both of operators are equal to true. So which means that this case gives us false, this case gives us false, the third case gives us false, and the last fourth case gives us value of true. Well, that's about a logical AND. Well, what happens if we would have a logical OR, which in C++ is being written as two pipes, so two vertical lines. So, two vertical lines, or logical OR, works in the following manner. And again, I don't use the most correct definitions because it's much easier than to convert our knowledge from simplified case till the most complicated one. So the logical operator OR gives you true if any of your operators which involved in this operation is equal to true. So here we have none of true, so result is false. The next case, one of them is true, so result is true. Next case, one of them is true, so result is true. And the last case, well, more than one of them is equal to true, so result is true. Okay, and logical NOT. So logical NOT can be created pretty easily. So in C++, it's written as exclamation sign and a variable or the value. So in the case of false, it becomes true, and in the case of true, it becomes false. So it gives you the opposite value. That's the idea of it. Okay, I'm not sure if I can put this into chat, but I can try. Maybe I will be successful at that. Um, okay, I guess it's not so. Okay, anyways, I suppose idea is clear about the superior operators. The only thing I would like to recommend you guys, if you have them involved in computations, like if you have the same case as I have here, right? When it's really not really clear what will be the priority of operations, uh, because maybe you could think like this operator will have higher priority or the lower priority than the logical operator you're using. So my recommendation would be to put both of operands of your operator into brackets, and then you can be 100% sure how it will be executed. Okay, so let me show you what I really think about this. I will be opening the FC++, because that's the one compiler I'm using to show you some examples. So let's say I wouldn't be sure which of these operators will be run first and which will be run secondly. So what I do, I just put brackets. And now compiler will know that 100% brackets will be executed firstly. Also, there could be the case when you would have a mix of logical operators. Maybe it could be something like this. So or maybe you could even have some not operator like this one. So you have all of those operators we overlooked, like exclamation sign, double ands, double or. So literally logical and logical or and logical opposite value. So um, so here I put them from the left to right in an order of priorities. So first you have to always run the logical NOT, always. So it has the highest priority of logical operations. Nextly, operator AND comes. And after that, operator OR comes. So just please keep this in mind. So it's something similar to multiplication and summation. So multiplication has higher priority and summation has lower priority. Well, it could be something like this. Okay, and return to our example. So we have the highest value from which we are starting. We have um, a condition. So one condition is correct, iteration will be executed. If condition becomes incorrect, then construction fails. Okay, and we have code which will be executed after each iteration. So let's take a look what we have. We can compile it and we can run it. I will choose another name of the file. Oh, okay. So here one bracket was had to be erased. And here we have the printouts of all of these even values we have in the range from 1 till 20. So there could be the question like, okay, here we have value of I bigger or equal to a 1, but referring to the previously ruled case, there could be the question why value of 1 is not being printed out, and answer would be pretty simple. So value of 1 will never be met because the lowest value I will be variable I will become will be 2, and after the 2 it will become 0 because 2 minus 2 gives you a 0. So that's the reason why we don't have value of 1. Are we good so far? Okay, great. So here we have a bit a bit interesting example, a bit more related to the real cases. So sometimes we don't even need the variable and its value, which is included into the looping system. So into for loop so-called settings. For example, as you can see, we have value of I changing from 1 till 5, and you see we never see a variable I inside the iterational codes, which means that this variable I is just used for understanding how many repetitions of iteration we have to do. Well, that's the only reason, guys. Okay, and then what we have here, so we have literally we went through this previous time, so we have the time function which gives you the integer value of the current timing, and it year, months, day, hour, minute, second, millisecond, and in specific cases even microsecond. Okay, and by the function sequence rand, this value becomes a starting argument for the chain of unpredictable randomized values. And if you will be putting just the same code each time, well, you will have the same values of randomized values so far. Okay, and here we have 5 times two indices. So here we have the value from a 0 to 5 plus 1, so it becomes from 1 till 6. Okay. Well, if we would try to use that, so what we would receive? Oh, okay. We would need some libraries like time.h maybe, and the standard library, std. I suppose we'll need these ones. Yes. So you see, we have those randomized values, and we have 5 times of this execution. So just to make a small reminder, so let's put some specific value here. For the beginning of the randomizer, as you can see, we have 1, 3, 1, 2, 6, right? Let's run the application again, and we have the same numbers. So they will be used all the time because of the randomizer has its own equation, and for that equation we have to give the value which will be unique for every execution of the app. Well, what else it could be besides the time? Okay, let's return this time 0, which gives the current time moment. And let's execute and run it again. Okay, we have 3, 4, 2, 4, 2, right? And if we would run the app again, so you see we have totally different numbers. That's the idea. Okay, I suppose you already understood this previous time. Okay, so by that, this small presentation has been finished, and maybe I can ask you to make maybe a few tasks, just to stone this knowledge. Okay, so the first one will be making the program to print the square of all numbers from 1 till 10. And once you will make that, you can post your code in the chat, or you can just inform me in the chat that you did it. Okay, maybe I will show the task again. No, it was here, yes. So how's it going so far? Okay, still working. Okay, maybe we'll need another minute for this. Okay, we'll open the definition again. So here we have one. Okay, do we need to take a look how to make the first task together? Okay, great. So the square number of the values from 1 till 10. Okay, so first what we'll be doing, we will be making the values, right? So we'll be having values from 1 till 10. So 1, 10, and we'll be printing their squares. Okay, so here, for example, I will put the following. So the value itself by by the name of argument. Okay, so we can do something like this. And then here we can make a computation. Oh, the square means that we just use, um, we just, oops, we just use the value such times as it has its value. So we literally making summation, but if we wouldn't have a summation, then it would be just a multiplication. That's it. Okay, so let's see how that works. Okay, variable I is not defined. So we can define that just in the first block, or we can just define it outside that. Okay, so we already have something. The only printout is kind of a bit terrifying. I suppose in the end of every of this text, I will put a new line symbol. So everything would be just separated. Okay, here we have one, but I wanted to use this value I. Let's run it again. Yes, and as you can see, we can have them. So guys, is it clear for you how we can solve this task? And while you're writing, I will copy maybe this code to the chat. Mhm. All right, all right. So you have the codes. Let's take a look maybe on the next one. So write a program to print each number from A to B in descending order, and A and B are entered by user. So guys, I suppose you remember how to organize the entering from the user side of the value. and you have to print values in the scanning order. Do we have any ideas how to make this? Okay, you stand correctly the silence, so you're trying to make that on your own. Okay, take your time, guys. Let's spend a few minutes for that. Okay, so time is moving on. So do we have any progress? Okay, so looks like there's the problem somewhere in the middle of the solution. Do we need to make the second task together? Okay, so discard in order, and both values are written by the client. But so we'll still be using cout and cin for printing out and printing in. I will say that I have an integer a and integer b values. Surely we can ask, like, a afterwards things which I received from the keyboard, it will be placed into variable a, and surely we will have a cout over variable b, and that value will be placed in variable b in a such way. Okay. The next thing, we have no idea which of them is bigger and which of them is smaller. What to do in this case? So if A is bigger than B, then we start from A till B. I suppose that's pretty understandable. The only thing we have to start with A because it will be the biggest value, and we have to end with B because it will be the smallest value. Yes. Okay, so what we will have here? Oh, and we surely have to, after each iteration, decrease the value. So we can print this out in a one line, and let's see what will happen. Oh, as I put incorrect operator, I put something else. We need to have a scene. Yeah, so let's say it will be maybe 30, and B will be just 10, so A will be bigger. Yes. So you see, here we have those printouts. Okay. Oh, and by the way, for sure, when there will be the else branch, the only thing which will be here different is just changing A and B places. That's it. Okay, so that's the idea. All right. So I suppose I can give you the task number 3 to be done fully. Mm, Okay, so again, your task is number three, and once you will have something to show, please post maybe the code, or maybe you can just write that you finished that. It will be fine as well. So are you somewhere in the middle of solution? Is everyone working on the task? Is there anyone who would like to show the third task solution? Okay, do we need to make the third task together? Because time is moving on and we have some more tasks standing and waiting. Okay, anyways, I will make that and show you how you can make it. So you have to have A and B entered by user, and you have to find out how many numbers in that interval are divisible by 3. Well, surely it automatically means divisible without reminder. So we already have A and B, and we can literally have different um, um, directions of computations. Okay, so if A is bigger than a B, so we go from A till B, otherwise we go from B till A. Okay, so we have this value I. Okay, how can we get if that's divisible by 2 without reminder? We take that value and we use the mode um, operator. So the percentage operator literally makes a conversion from literally finds out the reminder of division by the value which is mentioned on the right side of that. So which literally means that we have to make a comparison to some of the values. So for example, if I divided by 3 uh, gives you 0 as the reminder, so literally we found out that case. Okay, and let's maybe run it, compile and run, and let's maybe well, it's I don't know, maybe from 30 to 10. Okay, so as you can see, the values have been printed out, but only those which are divisible by 3 without reminder. Are we good so far with this solution? Was the solution clear for you guys? Yes, definitely. Good that you asked. Okay. Well, maybe let's fulfill this code here. So, yeah. So it would be in every of these branches. Yeah. So here you have the code. Okay. So we have something around 15 minutes left. Okay. Let's maybe take a look on another task. Well, which one to take? Um. Oh, okay. Let it be task number 5. So you will need to make a kind of computational table where you have number that varies from 1 till 20, and you multiply that with the value of 3. So you have to have these outputs on the screen after you run the codes. So guys, please try to make this, because it would be really nice if you would make some codes on your own. Okay, so I see the question in where you have to use void. Void. Um, about which void are you talking about? You mean void as the data type? Okay, let me take a look on the fifth task. Why do you need the void? You need the value from 1 till 20, and you print a such text on screen. That's it. You don't need the void. I don't even know why you imagine that you need a void, because void is a data type without a template. Most likely, voids are used as the pointers without a data type, and it's not our case at all. Okay, so you have maybe maximum some 10 minutes for this task. And afterwards, I would like to see maybe some of your solutions in the chat. And whenever it will be there or it won't be there, we will take a look on how we are capable to make the solution. Okay, so I'm pulling that task on the screen so you can see that. Yeah, so task number 5. So please start working on this. Oh, interesting. So Faustina's right that task 4 is done. Great, really great. And here we have its definition. So the program generates 10 random numbers in a range from -2 till 2 and calculates separate the summation of positives and negative numbers. Okay, since your friends, since your colleagues, since your colleagues are making the fifth task, maybe you can give those codes. Oh, okay, you forgot about summation. Okay, so maybe you can fulfill that task till the end, and you can share your sources, while others let's not to say struggling, but trying to make the task number 5. Mhm. Okay, so also this main the solution. Let's take a look. I will copy it into Dev C++, and I will take a look what we have here. Uh-huh. So we write and range. Okay. So we go for the value. Okay, let's see how that works. Okay, the integer, let's say 3, the range, let's say 20. Yes, so you have 3 multiplied with the value from 1 till 20, and you print out even the result of that. Well, yes, that's great. That's great. Okay, thank you, Oswaldus. Good solution. Okay, so the question for the rest of students. So did you make the solution for the task number 5? Okay, let's take a look what we have in the chat. Aha, doing the finishing touches. Okay, that's great. We're waiting for the solution. And we have something from Alona. Okay, let's copy the codes and let's see the output. Oh, okay. So here we have the n value written on the right side of the operator. Okay. Yes. Great. Great. Thank you. And we have some last minutes left. Um. So guys, please try to finalize your solutions. All right, so I suppose nothing can be done just in the last minute. So maybe it's the time for Q and A's. So do we have any questions about the for construction? Maybe there was something unusual for you. Maybe you have any questions about that. Okay, well, since there is nothing in the chat. Oh, wait a bit. Not really help to remember some things we learned in school. Ah, yes, because some of you definitely have had classes in the school related to this. Okay, so I suppose it means no questions and we are good so far. Okay, so if we're good so far, then I suppose on the next on this note we can literally finalize the class. Okay, so guys, thanks for being connected. I really appreciate that. Um, okay, okay, looks like 7 people is the maximum we can get this time. It's fine. It's really nice. Okay, so next we will be looking on another stuff of C++. So you're always welcomed to join the classes, guys. And for those who didn't submit assignments, guys, please don't forget about assignments. So here they are marked with this um, kind of soft pink color. So we have one home assignment, another assignment. So all of them must be finished in the end. So please don't forget about them. Okay, so again, thanks for being here. I really appreciate this, and I will definitely see you next time. Okay, guys, till the next time, bye bye, and have a nice evening.